So when you go to take your test over this weekend for lab, you might see this picture. And I might ask a question like this. Name that gland. And you would say? You would probably say nothing, but you would type. I'm just being silly. You would type thymus, right? I heard you. It was thymus. You are correct. So the thymus gland, thymus or thymus gland, okay? That's it. Now, that seemed like we were struggling with it. I picked probably the hardest gland that we haven't talked about in the whole week, all right? How about this one right here? Pancreas, good. That's the pancreas. You're not going to have a lot of questions from this picture. I'll just be honest. You might have one or two on the test. Out of the 25 questions on the lab test, 2/3 of them will be endocrine related. Probably one or two questions from this picture. All right. And then most likely one question from this picture. What gland is A? Pineal gland. And what hormone does it produce? Melatonin. Very good. What gland is C? Very good. Pituitary, because C is both the anterior and the posterior pituitary. What gland is B? Hypothalamus. Can you name two hormones that are produced here but are released down here? Oxytocin and ADH. Oxytocin and ADH. So those are the kinds of things that might show up. That's just a little backing up, a little review in there, a little reminding you about what we've covered. Ooh, which gland was this that I'm always going to show you a little fat on? Yeah, you could say adrenal gland or adrenal cortex if I show this, because it is the adrenal gland, but it's only showing the cortex. So if I put that up and I said name that gland, I would accept both. I would accept adrenal gland or adrenal cortex. Full credit. Perfect. What if I point here? What three questions might I ask right here? Okay, so I always, if I point in the gland, I could say, name the tissue type, right? Good. What tissue type is this? Cuboidal epithelium, just like most normal glands, okay? Most likely, the question would be one of the next two. It could have been that one, but most likely it would be, name this region. What region is this? Yes, it's that real long word, fasciculata, and the first word is zona. So zona fasciculata. And then the other question that would go with this would be, what do you think? Yeah, what hormone's produced here? And what hormone is produced there? Cortisol. There you go. There you go. And just for fun, what tissue is this? Connective tissue. Very good. That's connective tissue, and it's called the capsule. It is called the capsule. So here's where we're going to start today. There's a few things on this sheet that we haven't done yet. We've done all of the major glands that we're going to see pictures of and slide pictures of, but we need to come in and talk about some of these minor glands that you may not think of as endocrine glands because they do other things. On day one, we did the kidney. We talked about erythropoietin, and we talked about the pineal and melatonin, and we talked about the thymus and the thymosins. So here are the two we need to cover right now. I'm going to begin with the placenta. Okay, remember, after this, we don't have pictures, slide pictures, or histology to worry about. So we're just learning the content here. And with the placenta, there's not really much for me to draw, so I may not mark this up at all. We'll see. I think I'll probably write one word up there. But does anybody in here have a placenta right now? I mean, I don't know, because I'm not all up in your business. So what question did I ask while I was actually asking that? Yeah, if you're pregnant. Are you pregnant right now? Because only pregnant people have placentas. And mostly those pregnant people are which gender? Female, right? All right. So, almost immediately, this is what's so crazy. Almost immediately upon becoming pregnant, implanting, and once it starts to grow, you get a placenta very soon. It starts as a few cells and then the cells multiply. But those cells very early on start producing a hormone. Okay? And that hormone is abbreviated HCG, and its name is human chorionic gonadotropin. HCG, or human chorionic gonadotropin. And the primary purpose of that hormone is this. So do you guys know where the baby implants and where it grows? What organ does it grow in? Yeah, typically the uterus, right? That's where it's supposed to happen, in the uterus. So it's fertilized up in the tube. We'll talk about this later, fallopian tube. It travels for a few days, multiplying and growing, and then it gets into the uterus, and it finds the nice thick wall, and it implants, and it starts to grow. Okay, and the placenta starts to grow as well, and the placenta starts to make that hormone. So here's the number one thing. I know we have two things up there, and it didn't fully print up here, and that's okay. Number two. Number one is what I want you to know. The lining of your uterus. Does anybody know the name of it? The inner lining. So let me say, you've probably heard the disease that impacts that. It's called endometriosis. That lining is called the endometrium. It's not on this test. We'll learn that later. Okay? But that lining on the inside of the uterus, it needs to be thick or the embryo cannot implant. Okay? If it's too thin, if it doesn't have a good blood supply, it doesn't stick. Okay? Even if it's fertilized, it won't stick and it won't implant. So, every month you have hormonal changes that cause that to thicken. That's why you only get pregnant a few days out of the month. Comes in, implants. We want it to stay thick. So here's what HCG does. HCG helps the lining of the uterus stay thick, maintain its thickness throughout pregnancy. That's what you need to know, okay? HCG maintains the thickness of the uterine lining throughout pregnancy. You know, in our culture now, we always say, "Oh, here's a fun fact." That's just the way we talk now. I don't know where that got started, but that's what we say. So here's a fun fact. This organ is your only endocrine gland that's truly temporary, right? So I'm going to go ahead and put that up here just to kind of remind you. The only one that's temporary. And so when do you have the placenta? When you are what? When you're pregnant. All right. The next one is one of my favorite hormones to talk about. It has an abbreviation as well, and it's actually produced by the heart. But I'm not going to teach it on this screen. We're going to go, there's a lot to this one. It seems difficult, but this hormone makes so much sense. Morning. This hormone has two abbreviations. It's really odd. You know, almost every hormone we have, the last name of the hormone is hormone. So this hormone is commonly called ANH. I'm going to write its big name for you in a minute. I'm waiting on purpose. But this hormone happens to be a peptide, which most hormones are. But they chose for some reason to start calling it atrial natriuretic peptide. A lot of people now call it ANP, atrial natriuretic peptide instead of atrial natriuretic hormone. I will almost exclusively call it hormone because it's a hormone. We're studying hormones. That fits how we do it. But I just want you to know when you move on, if you're in nursing, maybe your updated nursing text or your teacher is going to say A&P. And if they say A&P like that, maybe they mean our class, anatomy and physiology, A&P, how we say it, or maybe they mean that hormone. All right. Here, anyway, here's the name. A-T-R-I-A-L, atrial. Does anybody know what the atria are? They are the top two chambers of the heart, okay? Your atria are your upper chambers of your heart. So that word is a reminder that your heart makes this hormone. No, your heart does a lot of stuff. Really, it pumps blood. That's the main thing that we like to know about the heart. But very interesting, cool thing about the heart is it makes this hormone. Okay. Where do all hormones travel? In the blood. Where's your blood go? Everywhere. So where's this hormone going? Everywhere. I'm just going to guess that most of you have never heard that word before. Okay? It's an odd word. And there's an H for hormone. Natriuretic. So what we like to do in A&P is break down the words. Because many times, even though you've never heard of something, if you know the roots, if you know the parts of the word, you can figure out what it does. So anytime you see this, here's what you should think of. Uretic refers to urine. Okay. And this part is the sneaky little part right here that actually makes it make so much sense. On your periodic chart, when you hear about chemicals and stuff, you know calcium is Ca. And gold is something crazy. What is it, AU? It's gold. They have all these crazy abbreviations, right? There's one abbreviation that you've probably done in A&P1, and here's the abbreviation. What does that stand for? Sodium. Well, look, there's a T. We're going to make it a plus. So it's actually sodium ion. NAT, Latin for sodium is natrium. So they put Na on the periodic chart to trick you. Instead of putting SO for sodium, they call it natrium. This hormone name, natriuretic, tells you exactly what the hormone does. It puts sodium, forget if I hold it, does that, into the urine. This hormone moves sodium into your urine. Okay. What organ in the human body filters your blood and pulls the waste out and makes the urine? The kidneys. So this hormone targets the kidney. Okay? This hormone targets the kidney. Travels through the blood and goes where? Everywhere, but its receptors are located in the kidney. Located in the kidney. I put nice little circles in this. Who can tell me what kind of tissue am I trying to show you that might be? Simple cuboidal. Very good. That's simple cuboidal epithelium. You don't need to write that down because I'm not going to make you memorize this little part right here. But in the kidney, We have tubes. And those tubes are most commonly a little single layer cuboidal cells, okay? And these tubes just so happen, and I'm gonna write over that in black, but I make it yellow because it's urine. Those are the tubes that will eventually produce the urine. So in the kidney, we have these little tubes that hold urine, okay? Right beside them, that urine is coming right out of the blood. So you remember how I draw a capillary? I just turned this one, okay? I turned it straight up because it's beside that too. So this thing right here is a little capillary. And so here's your basis of how the kidneys work. You have tubes and you have capillaries. You have two tubes. Blood's in the capillary, and in this other tube is a fluid that honestly, yet we're not supposed to call it urine, but it's gonna become urine. It will eventually be urine, okay? And so what happens is the kidney determines what might come over here or what might go that way. If it goes over there, it's blood. If it comes over here, what's it eventually gonna be? Urine. So look what we have here. This hormone, ANH, moves sodium which way? Into the what? Into the what? There we go. So it's moving it into the tubule, but we don't want to say the kidney because it's in the kidney already. It's already in the kidney. So it's going to move it into your urine. So here's what we want to do. We'll put sodium there because salt's always in your blood. And it moves that sodium, more of it, not all of it, more of it, over here. It's moving it over there. So it's increasing the amount of salt. Sodium is the most common salt we talk about. It's sodium, it's not salt. But a lot of people think of it as salt. It moves it right into the urine. Well, here's the really important thing about sodium. Sodium is from AMP1. You may remember this. Or from a biology class that you had some point in your life. Particles, little particles that are in a solution, are called a solute. They're called solute. And sodium is a very good solute. It's a very strong solute. And what sodium does is it always gets water to follow it. So wherever the sodium goes, water follows. So now we just had more water move into the urine. What's that mean? You just made more urine. You just pulled the water right out of your blood and put it directly into your urine. So you made more urine. So back to this, and I'm going to put some more stuff up there. This hormone, you gotta know the name, not just the letters, because the name tells you everything. Atrial natriuretic hormone. Atria tells us it comes from what organ? The heart. And natriuretic tells us it moves what ion? Sodium into what fluid? Into the urine. So it moves sodium into the urine. And then our job is to understand that wherever sodium goes, what follows it? Water follows it. So you're producing more urine. Well, our focal point in the body is almost never the urine. But this is how we understand it. Just like last time, what we like to know is what happens to the blood. So when sodium goes here and water follows it, we have actually decreased the amount of blood. So first we'll say the blood volume. And when you have less blood, now you have lower blood pressure. Absolutely. So what this hormone really does in the end, it drops your blood pressure. It lowers your blood pressure. This is your body's natural hormone to lower your blood pressure. If you know medications or know people that have blood pressure issues, they may take a medication called a diuretic. Diuretics cause you to get water out of your blood and make more urine. They make you pee. Okay? So this is your body's natural diuretic. What organ produced this hormone? The heart. What organ does this hormone target? The kidneys. Okay. And it moves what into the urine? Sodium. And what always follows sodium? Water. There you go. So then I like to also give you this. I'll put it up there in a minute. When's the last time you went to the movies? Hopefully you're not going to say, oh, this weekend I just went to the movies, because you're studying, right? All right. So when's the last time you went to the movies when you were in a new relationship? See, when you're in a new relationship, you get the popcorn. When you're in an old relationship, you're trying to sneak it in because it costs $5,000. Okay? You got the popcorn. What do you put on the popcorn? Butter and oil, right? It's got oil in it too, but butter and what else? Salt, right? How salty is popcorn at the movies most of the time? Pretty salty. You ever notice what happens to your lips when you're eating a ton of popcorn at the movies? It gets dry. It gets dry. It dries out. In fact, sometimes if it's one of those like 3-hour movies and you got the popcorn and you went and got the refill, by the end of the movie, your lips just might be chapped. Here's why. Because solutes, like sodium, you know what they do? You know, I just love this. They suck. You know what they suck? Water. They suck water. They suck water right out of the body. So when you get salt on your lips from that popcorn and it's got a little fat on it so it sits there and stays there, it just pulls water right out of your lips because solute sucks. Sodium is a solute and water follows it, okay? There's your memory device for this hormone. This hormone will show up, just want to remind you, in a couple of chapters later. So we're going to do this hormone more than once. Obviously, it shows up in the urinary chapter. And then we have a whole water balance chapter that it'll show up in. So this is a very important hormone, okay? Yeah, go ahead and get your picture of that hormone. Remember, the key to understanding this is knowing the name properly. Natriuretic means what in the what? Sodium in the urine. And if you can remember that, you can follow the steps. It puts sodium into the urine. What follows sodium? Water. So it makes more urine. We made more urine and we lost blood. We took fluid out of the blood. So we lowered our blood pressure. That is what we did. I better take pictures too, just because. So now what I'm going to do, we're going to talk more about this. I need a little room, so I'm going to change how I wrote some of this. Just made it a little bit smaller there. Do you remember what antagonists mean? Opposites. Opposites. Very good. Antagonists are the opposites. When we want to learn hormones that do the opposite, the easiest way to do it, and I know we have already mentioned this with insulin and glucagon, but I just want to remind you. So when you have opposites, pick one hormone and understand it, or even have a trick to understanding it. And so for me, our trick is this word. Natriuretic tells us what it does. So we always have a mental hook to figure out what this hormone does. The hormone that's the pure opposite of this, its name doesn't help you one bit. So you would just have to memorize it. Unless you know the hormone's the opposite. This one lowers blood pressure, so what's the other one have to do? It has to raise it. This one moves sodium into the urine, so the other one's going to do the opposite. It's going to move sodium back into your blood. And when it moves sodium into the blood, the water follows and it raises your blood pressure. So here's what I would like when you memorize. This is the part to memorize. The antagonist, the perfect antagonist to ANH is aldosterone. It is the exact perfect antagonist to atrial natriuretic hormone because it does exactly the opposite. So you guys tell me based on how I just spoke with you. Aldosterone must move sodium into what? Right, the opposite direction from that, back into the blood. And what is going to follow it? Water is going to follow it into the blood. So we get an increase in blood volume and an increase in blood pressure. Exactly the opposite of this. Now, I'm not sure if you remember this or not, or if I even said it. So maybe it's not remember. Yeah, it's probably not remember. It'll be remember later. So let me say it again. There is a fancy word in A&P that always means we're going to move something into the blood. If we're going to take it, we're going to be in the kidney, and we're going to take it, and instead of making it urine, we're going to put it back in the blood to get it back in the blood to raise the blood level. We're going to call that reabsorption. Reabsorption is the kind of fancy medical way to say you're going to move something back into the blood. So note, when you take your lecture test, you're not going to fill blanks in on lecture. You're going to just be reading questions and picking out the correct multiple choice. Notice, instead of saying aldosterone moves sodium into the blood, it could say causes reabsorption of sodium. When we say reabsorption, we always mean into the blood. So that's the way they say where they're moving it into the blood without moving it into the blood. I make a big deal out of this because I still remember when I was in physiology classes. The teachers never said reabsorption is a directional term that means into the blood. And we were doing all these hormones and all these things, and they would say, oh, this reabsorbs that, causes reabsorption of that, and this causes reabsorption of that, and this causes reabsorption of that, and they're going real fast. And they never once said what reabsorption means. So I remember my brain was going, what's it reabsorbed by? Where's it going to? You know, if they use that word, if I use that word, if the test has that word, it always means by the blood. Okay? It's reabsorbed by the blood. Just so happens there's another hormone that raises the blood volume and raises the blood pressure. It doesn't do it in the exact opposite way, but it's really close. Here's the name of this one. We finally get to it. ADH. ADH stands for anti-diuretic hormone. Uretic refers to what body fluid? Urine. Diuretic means makes you pee. A diuretic makes you pee. Is this hormone a diuretic? Look at its name. What is it? An anti-diuretic. So, are you ready to write something silly on your notes? I don't know if I have enough room to write it here, so I'll write it on the next screen after we get this picture. ADH makes you not pee. Okay? If a diuretic makes you pee, this hormone makes you not pee. Now, what am I really saying? It causes you to retain or hold on to that water. Or, as we just learned, the fancy way to say that, increases reabsorption of water. And only water. Not salt this time, not sodium. Only water. Only of water. So, when we move water into the blood, right? We have just increased the blood volume and increased the blood pressure. That's what ADH does. So, aldosterone and ADH, they work together. They both work together to raise the blood volume and raise the blood pressure. They just do it in a little different way. And that's what I'm about to write right up there for you. You are exactly right. Hormones that do the opposite, what do we call? Antagonists. Hormones that do the same thing or work together, we call synergists. Synergists. Now, synergists won't be a part of your lab tests. I can ask you about hormone relationships like that on this, but it will show up in lecture. So if you've already started your lectures, you've probably heard that. If you haven't started them, you're going to hear that, okay? Hormones that work together to accomplish the same goal, they call them synergists. Synergists. So this is a good place to get your picture. I'm done marking it up for this run through it. So notice we have ANH is the opposite aldosterone, and aldosterone is very similar to ADH. I also, when I first was remembering this, I remember saying, oh, ANH and ADH, those sound alike. So I made it in my head, they sound alike, but they're different. So they do the opposite, okay? But the perfect opposite is actually aldosterone, because it's opposite the exact same reason, because it moves sodium. ADH is opposite because it has the overall opposite effect, but it didn't do it the same way. And I will do this exact same markup for you when we get to chapter 26, because in chapter 26 we do all about water balance, and we'll do this again, so it will carry over. So once again, remember how we try to do AMP2. It's harder at the beginning than it is at the end. That's how AMP2 is. AMP1's kind of backward from that, all right? Okay, once again, if you didn't get that, get it again, or go ahead and snag it. And I'm gonna change it just a bit. There are two hormones that target the cardiovascular system on your handout. that come from the adrenal medulla. Anybody remember what two hormones come from the adrenal medulla? There you go. Epinephrine and norepinephrine. We'll abbreviate them real quick. Epi and norepi. What they do is they increase, one of them increases your heart's rate, and the other one makes it contract harder. See, when your heart is contracting harder and it's contracting faster, you increase your blood pressure. So we could say, check this out, we have 4 hormones on that side. All 4 of the hormones over there are increasing blood pressure. They're doing it in different ways. Every single one of them does it in a little different way. But they're all kind of the opposite to A and H. A and H is there to keep our blood pressure down, to help to keep the blood pressure down. Those are over there to raise the blood pressure. All right. Do you think more people have a problem with high blood pressure or low blood pressure? Yeah, more people have a problem with high blood pressure, right? So probably this hormone's quite active trying to keep our blood pressure down if more people are having a problem with high blood pressure. Okay. If you want to re-get that picture, especially this side, because we added that up there. Now, why did I put all that up there? Let me help you with this. Because when you're taking a test, and we've done so many hormones, it's easy for them to get jumbled, right? It's real easy. And remember what I said, just like with insulin and glucagon. If you have a memory device where you can remember one and you can know the others are the opposite, you're not going to miss them. You're not going to forget them. So look what I want you to add to your knowledge base for this, just to help you out. Because I could have a question on the lab test. Does epinephrine raise or lower blood pressure? Does aldosterone raise or lower blood pressure? Does ADH raise or lower blood pressure? Does ANH raise or lower blood pressure? It could be the exact same question with just the hormone name different. 4 questions like that. It ain't going to happen, but it could. Okay? And if you didn't lock them in, you would be going, oh my goodness, I knew they affected blood pressure, and I don't remember if it raises it or lowers it. So you ready for the easiest thing ever? ANH. Natriuretic. Sodium in the what? Urine. What follows it in the urine? Water. Water's in the urine. You just lost blood. This is the only one that lowers blood pressure. All of the others that we learned do what? They raise it. So there's your other memory hook. There's only one we studied that lowers blood pressure. The other ones raise it. I'm not telling you that's the only one in the body. Just telling you how we did it. That's the only one we talked about that does that. Okay? Boy, it's a good thing we didn't have a lot to do because this picture took a long time. So once again, this time I wrote more because I had space. Epi and norepi, they increase the heart rate and increase the contractile force of the heart. So it beats faster, and every time it beats, it pushes more blood. So once again, they raise the blood pressure, right? Increases blood pressure. But also something I didn't mention that's hidden in your handout is this word. Vasoconstriction. Do you know what that means?
Your vessels constrict.
Vessels, blood vessel. And what does constrict mean?
Size down.
Size down, perfect. Gets narrower, gets smaller in diameter, squeezes down, okay? That's what vasoconstriction means. So what if a hormone's job was to make your blood vessels get smaller in diameter, to squeeze down? What would happen to the pressure inside there? It would go up. So you have fluid in here. We're not changing the fluid. We're just squeezing the blood vessel down. So you have the same amount of fluid in a smaller space. The pressure goes up. So when you decrease the vessel diameter, right? That's how big it is around. You will always increase the pressure. Epi and norepi are vasoconstrictors too. So in addition to impacting the heart, they also make your blood vessels get smaller. So they help to raise the pressure that way. And the other reason I mentioned this is a very sneaky reason. Go on your hormone handout. If you have your hormone handout out, go to ADH. It should be on the what page? Or let me ask it this way. What gland releases ADH into the blood? Yeah, posterior pituitary, right? Notice there's a little sneaky word right under ADH in parentheses. Instead of vasoconstriction, it's vasopressin. Here's why that is. ADH has a second name. Back in the old days, they used to call it vasopressin. Some people still do. It's probably not as common. There's a lecture pool question that asks about that name. I'm not going to ask you that in lab. I'm not going to ask you about vasoconstriction in lab. What I put up there now is to help you for lecture, because I know there's a couple questions for lecture that show up like that. So if you want to snag that picture, let me write that, so you'll remember. This is likely to sneak in there on lecture. Okay. Okay, and this next one's fun. ADH, what gland released it, or what gland on the hormone sheet is it associated with? The pituitary. Which pituitary? Posterior. And what's the other posterior pituitary's hormone? Oxytocin. Well, we happened to go by oxytocin without really ever talking about what it does. Okay, so I'm going to add a little about oxytocin right now, about what it does, and I'm going to let you know. Oxytocin is our positive feedback hormone. Okay, I'll explain what that means in a little bit. Most hormones are not positive feedback. Almost none of your hormones are positive feedback. What would be the opposite of positive feedback? It would be negative feedback, and it would be regulatory, and I'll talk about that in a minute. But oxytocin, so let's draw this. There's a brain. Here's an ugly little pituitary. There's a big front, and there's a little back. Okay? And it's the back here, posterior, right there, that releases Oxytocin. By the way, remind me, where do our hormones travel? Through the blood. Don't you wish I could ask that question 5 times on the test? So the hormones travel through the blood. And where's your blood go? Everywhere. So look on that handout if you have it handy and tell me, what does oxytocin target? What 2 tissues? Uterus and? Okay, so you could also, just so you know, you could also say mammary glands, but I'm okay with you saying the breast. It targets the glandular tissue of the breast that is deep within the breast, where the milk was made, right? The milk is made in those glands. So, here's mom. Wow, that's a tall baby. That's a tall, furry baby. That's a tall, furry, hungry baby. There it is. It's in the uterus. There's the baby. Yes, this happens when you're pregnant. Unless you took a shot to drive the milk, those probably get bigger because they're going to be preparing to hold the milk. So those are the 2 tissues that this targets. But please don't forget, where does this hormone go? Everywhere, because your blood goes where? It goes everywhere. But there's our 2 targets. So here's the cool thing about oxytocin, what it causes. It causes smooth muscle to contract. There is smooth muscle in the uterus. There is smooth muscle in the glands of the breast, in the mammary glands. So whenever oxytocin gets in the blood and goes through the body and attaches to the uterus or attaches to the breast, it causes the muscle in that area to contract. Why are we trying to contract this muscle? To push the baby out, right? That's what we're trying to do, to push the baby out. So let me draw this, and let me help you understand why this is positive feedback. I don't know if you know, but the uterus doesn't start out really wide open, okay? It's got a little narrow opening, and at about the time of birth, it starts to open and widen and widen and widen. And then that baby's head comes down in there and stretches it even more. So there is stretch. Stretch is a stimulus. Hey, do you think your brain knows that your uterus is stretching? It does. It knows it, okay? Maybe you even felt it. You're like, I feel that down there, okay? But whether you're feeling it or not, there's signals going up to the brain saying the uterus is stretched. You know how the pituitary responds to that? It makes more oxytocin. And more oxytocin goes to the blood. And then that oxytocin causes this to do what? Contract. And then when this squeezes the baby, it pushes the baby down, and look, it pushes that cervix open even more when more of the baby's head gets there. So we just did more stretching. And more stretching means more signals to the brain, and that means more oxytocin, and that means more contractions, which mean more stretching, more oxytocin, and even more what? Contractions. You see how that's going the same way? It's like a loop. It keeps going. And this keeps going until you remove the initial stimulus. What is that initial stimulus? The stretching. So oxytocin, that uterus is stretched out. Oxytocin keeps going and keeps contracting that uterus, not as hard, but after you've given birth to the baby, you're going to birth the placenta too, and the uterus keeps on contracting some. And here's the cool thing about that. If you breastfeed the baby, every time you breastfeed the baby, what hormone is going through your body? Oxytocin. And oxytocin goes here and causes this to contract, and it actually pushes the milk out. If you've ever breastfed or been around someone that breastfed, you know, sometimes the baby's mouth slips off. You ever seen the milk go? Raise your hand if you have. Well, only a few of us? Okay, y'all need to be around more breastfeeding babies because it's crazy. I remember the first time I saw that, I was like, what in the heck? It could have hit Shelly from here. Yeah, easy, you know? You think the baby does all the work. The baby doesn't do all the work. The baby has to do the work, but the mom's body's doing the work too. Neat thing, whenever you breastfeed, oxytocin still goes to the uterus and it makes your uterus contract. So if you breastfeed your baby, your uterus gets back in shape faster. It's nature's process to do that, okay? Positive feedback means it reinforces whatever the initial stimulus was. So it pushes it to keep happening and keep happening until that stimulus is gone, okay? So let me ask you a real kind of basic question to help you understand this. When your blood pressure starts going up, do you want your body to tell your blood pressure to keep going up and keep going up and keep going up and keep going up? No, because it will kill you. If blood pressure was positive feedback, none of us would live. Because we'd start exercising, it would go up and it would just keep going up until we died. Okay? You want, when your heart rate goes up, do you want it to keep going up forever? No. For a purpose. All of those things that are for a purpose, those are negative, for those kind of purposes, are negative feedback. Watch this. If your blood pressure goes up, what does your body want to do to it? Bring it back down to normal, or keep it wherever you need to satisfy your oxygen requirements. But the point is, that's normal. It's a reversal. So they call the other type of feedback negative. And this is what's hard for people at first. Negative feedback is good. It's not negative. Okay? They use the term negative to mean opposite. I really wish they called it opposite feedback. Negative feedback is how almost everything in the body works. It's how most hormones work. Oxytocin is our exception. Okay? One other thing, since we're about to do blood, I'll just mention this for when you get to lecture. Blood clotting is also positive feedback. Okay? So oxytocin and blood clotting, those are basically the two positive things you need to know, positive feedback things you need to know for lecture. That's about it, to be honest. All right? So go ahead and snag that picture if you didn't get it yet. And then we'll take a 10-minute break. We are done with the endocrine system in lab. Take 10 minutes, come back, and we'll do blood. And I'll give you your blood lab handouts.
Did they move where we're